Welcome to the Explainer. So today, we're going to talk about a really fascinating way to train AI that can learn from all of us, but without ever compromising our privacy. It's a method called FedEwma, and its secret is giving the AI a special kind of memory.
All right, let's just jump right in with the big question. A question that's really at the heart of so much of today's privacy-focused tech. So how do you build one powerful, smart AI model when all the data it needs to learn from is scattered across millions of different phones and devices? And, here's the kicker, how do you do it without ever collecting that private data in one central place? Well, the answer is this really cool idea called federated learning, or FL for short. Think about it like this. Instead of all our data going to the model actually comes to our data. It learns a little bit from your device, a little from mine, and then it sends only those tiny lessons, not our actual data, back to a central server. You've probably seen this in action. It's the tech that lets your phone's keyboard get better at predicting what you're going to type next without ever actually reading your private messages.
But, as great as that sounds in theory, this amazing promise of privacy and power hits a major snag when it runs up against the real world. Because the theory is clean, but reality, well, it's anything but.
And that brings us to the core challenge here, something that data scientists call the non-IID problem. Now, I know, that sounds super technical, but the idea behind it is actually pretty simple to grasp. So this slide lays it out perfectly. In an ideal laboratory world, the data on every single device is IID. It's all nice and balanced, like a perfect miniature version of the entire dataset. But in the real world, our data is non-IID. My phone's data is totally unique to me. Your data is unique to you. It's all skewed and really, really unbalanced. And this analogy just hits the nail on the head. If you just average the updates from every device, which is what the standard method called FedAv does, it just doesn't work when everyone's data is so wildly different. It's exactly like trying to create a gourmet meal by just dumping a bunch of random ingredients into a bowl. The result is going to be a total mess. This chaotic process has a name. It's called client drift. The central AI model is trying its best to learn from everyone, but it's getting pulled in thousands of different, often contradictory directions all at once. This can make the whole learning process grind to a halt, become really unstable, or even just fail completely. And when it fails, well, that entire promise of private AI just falls apart. So how in the world do we fix this? Well, the answer lies in a new framework called FedEwma, which introduces a really clever solution to this exact problem.
Okay, so FedEwma's secret sauce is a technique called an exponentially weighted moving average, or EWMA. Now, don't worry about the long name. The key idea here is that it gives the central server a form of memory. It lets it remember what it's learned in the past and use that history to make much smarter decisions about the future.
And I love this way of thinking about it. Instead of the model lurching around wildly with every new skewed update it gets from a user, this EWMA method acts like a shock absorber on a car. It smooths out all the bumps and jolts, keeping the whole learning process steady and moving in the right direction. Okay, so let's break down how this memory on the server actually works. It's a surprisingly elegant and efficient process.
So it's this simple three-step loop, right? First, the server grabs the latest updates from some of the clients. Then, and this is the key step, it blends those new updates with its memory of all the past updates it's ever seen. And finally, it sends a new global model back out that's way more stable and refined because it's not just reacting to the latest bit of info, it's considering the entire history of what it's learned.
Okay, so the theory sounds great, but does it actually work? I mean, does this elegance on paper actually lead to better performance in the real world? Well, the researchers put it to the test. And the results? Well, they pretty much speak for themselves. Looking at the classic MNIST dataset, that's the one with handwritten digits, FedEwma gets a significantly higher accuracy and a much, much lower error rate compared to both the standard FedAv and even another improved method, FedProx. It's not just a little better, it's a real step up.
And this wasn't just a one-off thing either. We see the exact same story on the more complex Fashion MNST dataset. FedEwma consistently comes out on top, not just in the final score, but also in how stable the learning is from round to round. That memory, that shock absorber, you can see it's really, really working.
Now, this is about more than just getting slightly better scores on some academic benchmark. This increase in stability has some really profound implications for making this technology actually useful and reliable out there in the real world.
So if we boil it all down, what's the big deal with FedEwma?
Well, it tackles that client drift problem head-on. It learns faster and more stably, and it gets to a better final answer. And maybe the best part? All of this is done with a simple change on the server. The clients, our phones and devices, they don't need any complex modifications at all. It just works.
And this is where it gets really exciting. By solving this core stability problem, FedEwma helps move private AI from just a promising idea in a research paper to a practical, robust tool. This is the kind of breakthrough you need to make it work for really sensitive fields, like diagnosing diseases from medical scans across different hospitals or detecting financial fraud across different banks, all without ever having to share the underlying private data.
So, this leaves us with a big, exciting question. We're just starting to scratch the surface of what's possible when AI can learn collaboratively and privately. Now that we have more robust frameworks like FedEwma that make the whole process reliable, where is this privacy-first tech going to pop up next? The potential is huge, and we're just getting started.